Right. Hello. This is Thursday, fourth day of my experiment. I think it should be worth noting that tomorrow there will not be any video. Today I was trying to get around to telling you that, but I guess I'll just make the video. It's not what I planned to do, but I will do it anyway. So I'm just going to teach you something very short. Today's lesson is going to be kept very short. So let me just get this down real quick. What you want to do is learn PEMDAS to some extent. Understand that this is not 100% accurate, but it's accurate enough at this level where it's not going to matter too much. But don't go in over your head, alright? All this really is a tool to memorize the order of operations. So P stands for parentheses. Whoops. I accidentally hit Shift Enter. I hate when that happens when you press it and it just does not go a space down. Anyway, the E stands for exponents. The M stands for multiplication. The D stands for division. I'm running out of space here. I need to shift myself just a little bit more higher up here. And then there is addition and subtraction. Oh, no. Whatever. You got the point. Yeah, so let's just go over it. God, alright. Let me expand this canvas before I make any more mistakes. That should be enough. Yeah. Okay, so basically all we need to start off with is an example of something I have done. And I'm not going to worry too much about you learning how to do it, just more on the fact that I will explain to you the order of the process here. So let me just quickly grab something. Nothing too complicated, nothing too fancy here, just something I could do just to show you my process. Nothing on my desk at the moment as an example here. I'll just make my own example. Okay. So let's do a little bit of this. Okay. Pretty sure this will have. There we go. So now this has everything in it. This 2 up here above this 9 is an exponent, and these little symbols here are parentheses. We have, oh, you know what? Let's also change this up a little bit. Let's just make this subtraction so we're actually using everything. Yes, this is good now. Okay, so we have literally everything in this problem. We have parentheses, we have exponents, we have multiplication. Well, you may not see it at first, but actually, when you put a number right next to a parentheses, let me just show you down here real quick. If you do parentheses like so, and any number, right, doesn't matter which one it is, and I'm writing X here as like algebraic symbol here. So maybe it's better if I just did n instead, which also serves as it. Not to confuse anyone with multiplication here, but n stands for any number here. And we have here, let's say, yeah, another variable here. All right. So we have two symbols here right next to each other. We have parentheses in here, and we have another variable out here. What this is essentially saying is we're doing m times n, and that's all there is to it. Although you don't want to be using this symbol anymore. This X symbol is probably want to be ditched. You want to start doing things like this, as this will be a lot faster, convenient, and a lot more in this align with the syntax of what you will do in the future, if you are gonna stay there. If you're just taking this class to brush up on your math skills, that's also fine. You don't need to worry about it then. But just so you know, that is how it's done. Okay, so anyway, back up to this problem now. We're gonna do it like this, very short, so I can teach you the process. We're going to start off by solving what's in parentheses here. So this is the first thing we solve for, are all things in parentheses. Now, believe it or not, we're actually looking at not just two parentheses here, but actually additional two more because of this division symbol here. Yes, believe it or not, we are dividing. What's happening here is that we have to deal with the parentheses that are invisible. There actually is an understood parentheses between the top and the bottom here. They must be done before the division is done. Just understand that. When you see this division symbol, the fraction symbol, that will be what decides. Alright? This essentially is saying this. I may have talked about this previously in another lecture, I don't remember, but if I did, this is what I'm referring to. That fractions are actually telling you what parentheses are, and parentheses are important in the whole grand scheme of things. Note that this right here, n divided by m here, right, is not the same as they are not the same problem. They are completely different. This is why it's important to understand this kind of stuff. But you will see that this right here is essentially equal to that. Yeah. But let's not worry too much about that, alright? All you need to know is there are moments where it's not true. So, once again, I'm going to talk about parentheses here. I'm going to deal with solving them first. We have to deal with parentheses number 1 here. 7 plus 9, 16. Enough stalling. We're going to just expand our canvas even more here. Do not think I need to, but I actually do. So this is the same as writing 5 times 16 over 9 to the second power minus 10 times 0. And the little trick thing about 0 is that anything times 0 will always be 0. So we can already just say that this is the same as writing this over here. Alright, so we have this all figured out now. Understood? Understood? Great. If you don't, then you can always ask me in the comments and I'll always answer. I am not that shy when it comes to answering math questions. Although I'm not very good at explaining a lot of the stuff I do say, so I do apologize if my reply is not actually adequate enough. Anyway, before I get even more off topic, let's continue. The next thing we need to do here, before anything else, is that we need to discuss this 9 to the second power here. So while, believe it or not, we did skip a whole step here, it's not going to matter all too much because there's actually a separated minus symbol here. And we're not going to worry about that because it's not going to change a whole lot here. You should know that right now, even though exponents is in the second order, this is not going to change anything because this will always be 81 regardless of how it's done. This will be 81. 81 minus 10 times 0 is the same as that. They're both the same. You should know this. But it's only because 0 is there. Otherwise, we will just need to do this. Well, not all the time. Honestly, if you want to go ahead and wing it, go ahead, do it. But you should know that this is the priority here. The exponents is the priority. The logic flow here. We are all separated by additions and subtractions. And it's true, we can all do what's in between the spaces of a minus and a plus sign as long as we follow these 4 things here before we deal with this. This is what separates this, the PEMD, right over here. A plus and a minus sign will allow us to do these operations without any issues. But I believe I may have lost some of you because of this whole little skip here. We did do parentheses first, right? And we are doing exponents. You don't need to really care about what that is. All you need to know is that that answer is 81. But if you do know that it's just 9 times 9, and you already know 9 times 9 by now is 81, then you're good to go. You don't really need to learn more about that. I will go over exponents in just a bit, but right now let's just focus on learning this order real quick. So we done this already. Now let's rewrite this again. So we have to erase all this because this does not really matter. This isn't real. Let's start writing down what's actually happening here. Alright, so then this is the same as 5 times 16. 5 times 16 is 225 plus 6 fives, plus 30. And if I'm not mistaken, wait, hold on. I'm getting ahead of myself. I thought it was something else. No, it's not 225 because I was thinking of what's it called, 15 times 15. And unfortunately, that one in my head just existed. So yeah. No, this is just 5 times 15 plus 6 fives, which is not that which is not that much of an issue here. Well, no. Actually, no, it's not that either. What am I saying? Just do 5 times 16. Stop looking for this dumb shortcut. This is so simple. All you gotta do is do 5 times 16. Add 16 fives. Jesus. Okay, I could do this. Alright, we have it. We have it already done. Alright, we have 40 plus 40. 40 plus 40. 80. 80. Alright, there we go. What I did was I broke that 16 into 2 things. I broke that into 5 times 8 plus 5 times 8. So I can do this in my head a lot more faster. And I just told myself not to do a shortcut. But, you know, it's still the right answer anyway. It's not wrong. I plugged it in my calculator too just to make sure. Yep, that's right. Everything is all according to plan. Alright, and there you go. There's our answer. We are off by 1 here. It's just unfortunate. So we don't have a whole number. This is a very close number to 1. Super close to 1. You could mistake it for a 1. But, you know, it's not a 1. It's in this form here. It's not exactly 1 yet. It's really close, though. This is the right answer. If you plug this all in into one of those TI-84 Texas Instruments, then they will probably net you this answer. I say probably because I didn't double check this. I just made this up on the spot. I could be wrong here, but the order of operations is done correctly here. So, yeah. I am certain that this is the answer. Alright, so let's actually do this. Let's explain this all process slower, a lot more easily to understand, and a lot more clear. Yeah. Just the same thing. I'm just repeating myself at this point. Repetition is the key to success. I think somewhere someone told me that. That's why I remember that. Anyway, we have parentheses 8 times 3 to the second power. Let's just get this over with. So the first thing we need to do before we start anything, actually let me change this. Let's change this into something we do know for right now, so we can make this a lot more faster and efficient. 3 times 3. Alright, so let's start with parentheses. The first thing we need to do is solve what's ever in parentheses, which means we need to move on to, again, PEMDAS. Do we see any parentheses within the parentheses? No. Do we see any exponents within the parentheses? No. Do we see multiplication within the parentheses? Yes, there's a multiplication symbol right there. And all we need to do is do that together. Alright, so now we have 9 to the second power. Alright. Now it's all by itself now. There's no more addition, no more subtraction, which means the parentheses can now be finished. So now we have 9 to the second power. Now, there are no parentheses, so we gotta move on to something else. Now there are exponents. We must do exponents. What this basically is telling us to do is we're doing 9 times 9 within parentheses here. That's a terrible looking 9. It doesn't even look like a 9. God, that's awful. Alright, so what it's essentially just telling us to do is do 9 times 9 within parentheses, like so. No big deal. We'll just do that right now. So what we have here is, in fact, a very simple thing to do. 9 times 9 is 81. 81 is the answer. It is the only thing left. It is the only number. This is not telling us to do any addition. It's not telling us to do subtraction. This is our final value. We are done. We have solved this problem. Now, we didn't do a whole lot with the adding and subtraction, but if there was, they'd also come like last after this. So let's start over this problem again. But this time we know that this is all 81 on the left here. We did all of that already, so we know this is 81, and we're gonna just add another thing happening over here. Let's add a 10 times 2 here, also to the second power. Okay, so then we have to do is the same thing we did on the left side. We know that this is 81, and we could theoretically just write this as 81 plus that, but we're not going to do that. We're going to solve this, solve that separately, and then we're going to talk about the addition and subtraction. You notice that as we're doing this, we're just going to break it down to just one number, and the subtraction and addition here will be the ones, like I said, to separate these. The PEMD is separate from the AS. Although you must follow the rules here whenever you're checking what you're doing. I mean, you don't want to go, let's do 3 plus 3 times 3. Alright, let's have 6 times... No, don't do that. That's wrong. Don't do that. That's just not right. That's so wrong on so many levels. Don't do that. Don't be the person to add before you do the multiplication. The order is multiplication, division, and then add subtraction. Not add first. So what you want to do is, instead, you do 9 3 plus 9. I'm reading it right to left there. Sorry about that. So 3 plus 9. That's how the order would be in this example. But addition is not there. The addition is right here, separating between the parentheses. Now, I just want you to think about this a little carefully. It doesn't matter what's in that parentheses, alright? It doesn't matter what's in the other parentheses. As long as there is an addition symbol right there, right? These things will have to be done before we can move on. Otherwise, nothing can happen. This x and y here are simply algebraic variables here telling us that they could be any number, doesn't matter what, any number, two different things. We'd have to solve them before we can put them together. This addition here is what's keeping them at bay. They must be solved before the addition could be started. So, enough stalling, let's get this over with. 10 times 2 is 20. 20 times 20, within parentheses, because the exponent is telling us to do that, is 400. Remember that little zero trick I told you about? Yeah, it still applies here. Just do 2 times 2, 4, add the 2 zeros at the end, and there you go. That's what happens. But also because I remember this as 400. It's just, I remember my square roots, not my square roots, my powers all the way up to 20, and that's about it. Can't tell you more than that. Yeah, so there's that. We have 400 now plus 81, and this is just 481. No big deal. Very simple. Too easy to explain. It's just how it goes. So let me go ahead and talk about another example, but this time a lot more clear, because I just brought that up in the middle. Yes, I'm doing this again because I'm not very methodical about my approach here. Sorry about that one. So let's go back to the previous example I was talking about with the 3 and the plus and the 3 times 3. Yes, let's talk about that. Maybe not gotten it all where, but yeah, this is just wrong if you do 3 plus 3 first. You need to do 3 times 3 first because that's the order. We're going to read left to right like an English speaker here. And we're going to say that multiplication must be done first. Now, I know what you might be thinking. Multiplication, then division. No. That's probably not what we're going to be doing. No. Nope. Can't do that. Think of PEMDAS as 3 whole things. 3 whole steps. P and then E are all in one group because they're technically both the same thing. Likewise, with multiplication and division, they're basically the same thing, only done differently, with different parameters and different rules. And addition and subtraction are similar things where they change a value by making it go in a direction, whether it be a positive direction or a negative direction. They're also in one group. So there are 3 whole steps in total to PEMDAS, where you must follow this order. However, you must do parentheses first. Parentheses follows this first step here, as it does have priority over exponents, unlike these two. So despite that being another thing paired together where they are almost the same thing, exponents are just parentheses in their own way. This is because of a very simple thing. Parentheses within a parentheses must be done first. If there is a different type of parentheses outside, which an exponent is, if it, for example, we have a number here to third power here, we'll have to do whatever this problem wants us to do before we can do this, because essentially this is what this is saying, is to do whatever this problem is 3 times. Yeah. So believe it or not, we have the same order of operations here. We don't need to worry about the exponent because there's just parentheses here. We just need to do each one on their own. So in the end of the day, the thing in the center will have to be done before anything else is done. Alright. I need to explain that too afterwards, because once again, I'm not very methodical. Let's go back to what we were talking about here. Right? 3 times 3 must be done first, because this is in the second step. There is no first step here because there is no parentheses, nor are there exponents. Although technically there could be, there is not in the situation, because there are no defined parentheses. And because there are no defined parentheses, right, if we add a 2 here, then we have to change a lot of what's happening here. But there is not a 2 up here in this, up here, right here. Nope, not at all. Instead, what we gotta focus on is doing 3 times 3 first. 3 times 3, we're in the second step, no parentheses and exponents. So we're doing 9 here. And then addition and subtraction. What we have here is an addition between this value here. So 3 plus 9 is equal to 12. That is our final answer. There's nothing else to do here. There are no more symbols. So we're all done. All said and done. Alright, time to quickly explain exponents a lot better than anything. Alright, so as you've seen previously, this 2 here, I say this as the second power. Don't need to worry about how I say it, even though it is proper and you must know to say it like that too. All you really got to do here is know that if you have any number, once again, any number, I'm defining this as n, right? What you're essentially just telling it to do is do this is multiplied by however times you need to do it, defined by the exponent. So if it's telling you to do 2, it's telling you to do 2 n's. So n times n. This is expressed as a power. Alright, so what have we learned? We have learned that this is essentially just an exponent problem, and that we have some work cut out for us in the future. Yes, believe it or not, exponents and parentheses are a little bit difficult to understand. In order to understand parentheses and exponents, we need to use them a lot more. So you have, once again, some homework to do. Despite this being a very short explanation, you can come back here as many times as you want to try and learn this as best as you can. So what I have you to do is I want you to come up with your own problem that uses all of these, all of them, yes, all of them, and I need you to solve it correctly, and I will come over there. If you can send me an email of your work at this following email, if you can show me your work, take a picture of it or whatever, send it there, I will review it. I will review it. Make sure you put the subject though as math experiment, because I might not be able to see it. So yeah, that will be how I check your work. If, however, you're not like required to do that, like for example my mom, who is watching this, Mom, all you need to do is text me. I'll just review your work. If you have a problem that uses all of it and I see that you have done it very well, then yeah. But as for everyone else, no, I'm just gonna worry about the emails thing, because I sometimes don't really check that. But I made it just for this, so I don't get a bunch of issues. Don't get a lot of a lot of spam. So yeah. But yeah, that's all there is for today. Yep, take care. Nothing more to learn here. Oh, except nah, nope. I'll tell you about what we will be doing next time. We'll be learning more about the square root of any value and what it means. Because believe it or not, this is also a form of parentheses. A form of parentheses with an exponent tied to it. And that exponent happens to be a fraction. Ooh, scary. Till next time, this will be haunting you. How do you do that? That is so weird. That makes no sense. And a little sneak peek. I'll give you a little sneak peek. All that is saying is this. Actually, no. I'm not gonna tell you. You'll have to wait till next time. Sorry about that. I don't mean to hold you by the neck or anything. I don't want to talk about it right now. It's a little bit complicated. It's not that complicated. Just tired. That's the truth. The honest truth is that I'm tired. So sorry about that. Anyway, later. Good night, everyone.